Hello, friends. Today we're going to talk about real world problems having to do with similar figures. We're going to solve for missing parts of similar triangles in the real world. Our state standard, know and apply properties of geometric figures to solve real world and mathematical problems and logically justify results in geometry. Avery puts up a radio antenna tower in his yard. Ella tells him that their city has a new law limiting towers to 50 feet in height. How can Avery use the lengths of his shadow and the shadow of the tower to show that his tower is within the limit without directly measuring it? So if we look here, we have two similar triangles. And we're looking for the height of the tower. And remember, it needs to be under 50 feet. So I'm going to do the small triangle over the big triangle. 5 over 40 equals 6 over x. And then solving this one, 5 times x is 5x. 6 times 40 is 240. So solving this here, we'll divide both sides by 5. And it looks like his tower is 48 feet tall. Make sure that you're labeling for these word problems. I know it's feet because there's feet in the problem. So 48 feet tall. If the tower were 50 feet, so now they're telling us that this is 50 feet, how long would the shadow of the tower be? So these are the shadows. For all of these triangles, or for all of these problems, the shadow is going to be on the ground. And then the height is going to be the one that's up and down. So we're looking for x here. I can use the same type of proportion that I just used. I'm going to do the small triangle on top, big triangle on the bottom. So in this case, we'll say 5 over x equals 6 over 50. And then solving it, 6 times x is 6x. 5 times 50 is 250. So if we're dividing both sides by 6, we will get that the shadow is 41.7 feet. So the shadow would be 41.7 feet long. And of course, just like we did before, you can always plug this back into your original proportion here to make sure both sides are equal. A pole 3 meters tall casts a shadow 4 meters long. So 3 and 4, that's the pole. A nearby tree casts a 15-meter shadow. So there's the shadow of the tree. What is the height of the tree? We'll call that x. I'm going to do my big triangle on top for this one and my small triangle on the bottom. Remember, there's a bunch of different ways we can write this. I'm just going to do it this way. There's like 4 different proportions you could possibly write. X over 3 equals 15 over 4. And then solving this one, 4 times x is 4x. 3 times 15 is 45. And then dividing both sides by 4 to solve this, we will get that the height of the tree is 11.25 meters. Meters is our unit for this one. So we got another one. To find the length of a pond. So here's the length of our pond, is this part of this triangle. A surveyor took some measurements. She recorded them on this diagram. What is the length of the pond? It may be helpful for you to redraw one of these triangles so they're kind of facing the same way. I'm going to redraw my smaller triangle. So it's facing this way. I can see that the right angle is at P. The shorter side is from P to L, which means this is K. It looks like from L to P is 3 meters, and from K to P Oops, I messed up my L and my K, did I? Oh, I messed up my L and my P. There we go. P is at the right angle, and then that's L. There we go. So from K to P is 12 meters. So now the two triangles I'm dealing with are these two triangles. I'm going to have my big triangle on the top and my small triangle on the bottom. So x over 12 equals 5 over 3. Again, there are many ways you could have written that to begin with, but you'll get the same answer each time. 3 times x is 3x. 12 times 5 is 60. Dividing both sides by 3, we would get that the pond is 20 meters long. Last one here. On a sunny day, Josie's shadow is 2.9 meters long, while the shadow of a tower is 11.3 meters long. If Josie is 1.8 meters tall, calculate the height of the tower. Here they already have the h there for us. So I'm going to do the small over the big. Maybe you've noticed this. I always just do whichever triangle's on the left, I put on top. Whatever triangle's on the right, I put on the bottom, but it really doesn't matter. So solving this, 1.8 over h equals 2.9 over 11.3. And then solving this, 2.9 times h is 2.9h. 1.8 times 11.3 is 20.34. And then dividing both sides by 2.9, we would get that the height of the tower is 7.01 meters. All right, so sometimes you have to figure out what length they're asking you for and label that X. Set up your proportion, solve it. Do not forget to label your answers. Thanks, friends. Have a good day.